going to do is we're going to practice factoring. So you remember how to factor. So, first question, factor it. What do you have to do? Simon method. Things that multiply to be 6, add to be 5, 3, 2. So you have x plus 3, x plus 2. Next one. Simon method. Things that multiply to be negative 8, things that add to be 7. If you're doing this, things that multiply to be negative 8 and add to be 7 is 8 and negative 1. So your factor would be x minus 1, x plus 2. Like next one. A little trickier. It's things that multiply to be negative 10, add to be negative 9. You'd have negative 10 and 1. Remember, your a value isn't 1, which means you need to set up your factors like 2x minus 10 and 2x plus 1. And you have to divide one of these by 2. We're going to divide the first one by 2 because it's the only one that divides by 2. And it's x minus 5, 2x plus 1. If I ask you, what are the x-intercepts of this graph? What you do is you factor, like we've done, and then you figure out what values of x make each thing 0. Right? So it would be 5 and negative a half. Oh, it's 2. 1 over 2. Negative 1 over 2. Okay, this one. What's the very first thing you always look at if you're factoring? Greatest common factor. Is there a greatest common factor? Of course. So we take the 3 out. We have x squared minus 3x minus 10. Things that multiply to be negative 10, add to be negative 3 would be negative 5 and 2. That means your factors are 3, x plus 2, and x minus 5. I'm going pretty fast through those because you guys should be really good at that by now. You've been doing it for 2 years, and we've done it basically for 2 months in this class. It doesn't matter the order. Order doesn't matter. It's multiplication. Nope, that's a great question. That's what I was going to ask. If you're asked what your x-intercepts are, and you get an answer like this, your 3 doesn't affect your x-intercepts. Your x-intercepts are negative 2, because that makes this one 0, and 5, because that makes this one 0. The 3 in front has nothing to do with it.
So the original 3x squared and the back version have the same intercepts.
Exact same intercepts, yeah. Okay. That should be reviewed, right? Most of this should all be reviewed. Without graphing, write all that you can to determine about the graph. So let's write out everything we think we know about this graph without graphing it. What's the first thing somebody knows? Soccer.
What I noticed is, do we have to take out greatest common factor right now, or should we?
All I'm asking you, I'm not asking you to solve it, I'm not asking you to factor it, I'm just asking you, what do you know about this graph without graphing it? Ty. You could put it into vertex form. Before we convert it at all, what do we know about this graph, Logan? Where's your y-intercept? Hey, Logan, you got like 6 voices. That's your y-intercept. So we know our y-intercept is equal to 0, negative 20. That's one thing we know. Do you got a question? Answer.
Because the negative isn't open to
That's a great question. Because our a value is negative 2, will that tell us the direction it's going to go?
yeah, so it opens.
Yeah, it opens downwards. There's a reason why both your formats have A and A, but all the other values are different. Some of you realize that your A values will end up being the exact same in both formats. So yes, that tells you that it opens downwards. Yep, down. Which means it has a max. That's great. What else do we know? In this format, is there anything else we know? We have that. Nothing else we know? Okay. The next thing you need to do is start changing it into different formats. The easiest format to change it into is factored form. Factored form is way easier to change into than vertex form. And we'll get the same results. We'll find the vertex by finding the factors, and I'll show you how. So let's change this into factored form. Greatest common factor is -2. That leaves you with x squared plus 7x plus 10. Things that multiply to be 10 and add to be 7. 5 and 2. Okay? Factored form tells you two things. What does it tell you? Both your x-intercepts. Tells you one x-intercept, tells you the other one. So where are our x-intercepts? Exactly. So x-intercepts are at -5, 0 and -2, 0. Right. Yep. What's your axis of symmetry? So I'm going to call it A of S. Your axis of symmetry. What is it, right? You're right. You don't know? That's okay. Hand up if you got a suggestion on how we're going to find axis of symmetry. M-Dog. Yes. It's the middle between these 2 points. So if we're on a number line and we're at -5 and -2, we need to find the middle point, and that'll be your axis of symmetry. What is your axis of symmetry, Zocker?
Don't you take the bigger number, add the smaller number of the x and stuff, and just divide that by 2?
That'll work. So what do you get? It should be -3.5. Because if this came in 1.5, you're at 3.5, and if this came up 1.5, you're at 3.5. So your axis of symmetry is at x equals -3.5. We're doing pretty good. There's one more thing you can find out. How do you find your vertex? It's your axis of symmetry. Axis of symmetry. That's a good question. Okay, am I good to erase this side? Yeah. So, Logan's got the answer. You know the x value of your vertex. It's -3.5. But we don't know the y value. So if you take -3.5 and put it in for x, you'll find your y value at that point. That's your vertex. So y is equal to -2 times -3.5 squared minus 14 times -3.5 minus 20. That means y is equal to, you're using your big one. 3.5 squared times -2. We have -24.5 plus 49 minus 20. Your y value is equal to vertex, so vert, is at negative 3.5, comma 4.5. The big thing is, we just figured everything out without graphing and without going into vertex form. Going to vertex form is difficult. It's very difficult. So when you can avoid it, that's usually your best play. There's a lot of intricacies to getting into vertex form that can be missed. My suggestion is if you can avoid it, avoid it. Okay? That's note page. Here, it's a beautiful note page review of what quadratics look like. The fact that we can use our x-intercepts to find things. It's basically what we just did is just laid out no lies for you. So if you need to look back at something, you can look back at this. Sasha.
But like the first two documents were the same sign, like having x-intercepts. Like,
That's if you're in, yes. That's if you're in vertex form. Yeah. Okay. If you want to read through that on your own, we already discussed it all, so we don't need to read through it again as a class. Identify the intercepts, the equation of the axis symmetry, and the coordinates of the vertex of the graph. So, we can find a little bit of everything. And we're going to do it without graphing, because we want to know how to actually do it. Graphing is a escape plan if you're ever really lost. But remember, we set up your test that most of the questions you can't graph. We do that on purpose. We want you to be able to do the math.
you set it up so you can.
There was lots of questions yesterday, so for instance, where they just put x minus w squared, and they say, how far to the right is it? It's w to the right. That's how many it is, right? So you need to know what's going on. You can't graph it.
I was just like, they give you a
Yeah. If they give you this, you can graph it.
but if it's letters.
But if it's letters, you can't. And it's going to be letters.
Why?
That's the question. We need to understand how the numbers work so that numbers or letters make sense later. Like, you can't visualize on a graph where letters work. You know what I mean? Because W could be anything, so you could be anywhere on the graph. So it's hard to actually analyze graphs with letters. Okay, let's do the first one as a group. Where's the y-intercept? Where's Dante?
It's 0.
The y-intercept. 0, -5. Remember, if you get given a y-intercept, the point of x is 0. Good job. What else do we know? Scott.
Upwards. And if we don't have a C value, or rather,
It is possible to not get a C value, but if there's no C value, it's 0. So yeah, that would mean we're at the origin for our y-intercept. Okay, it's facing upwards because we have a positive A, which means we have a minimum point. That's good to know. What else do we know? Do we know anything in this form? No. So let's factor it. Let's put it into factored form and figure out everything else. It's possible. So, what I'm going to do, zero is equal to 0.5 squared minus 1.5 x minus 5. The reason I changed that to 0 is because that's how we always factor things, right? That's why things work. It's because it's equal to 0. If you're looking for your x-intercepts, that means y is 0. That's why we're able to change that. Okay, a lot of people want to factor out a half, and that's not wrong. It's a lot easier to multiply both sides by 2, and then you don't have anything outside of the brackets. So, if I multiply both sides by 2, what's 2 times 0? Still 0. But now all these numbers are nice. 2 times a half is just 1. 2 times 1.5 is just minus 3x. 5 times 2 is 10. If you have 0.5s, you can multiply everything by 2, and it'll get rid of all your 0.5s. You're right. So, and that's why I wanted to do it this way, because you don't put it out front like that we used to, because we've already done it to the other side. We used to put it out front because we used to have y equals and not 0 equals. But if you have 0 equals, you don't have to put it out front. Soccer. Okay, because I'm looking for x-intercepts, which means y is 0. So I changed my y to be 0. Hi.
Okay.
Answer the question.
The y intercept.
Right. So that's the y-intercept. We're doing x-intercepts now. Yeah. Okay, factor that. Things that multiply to be negative 10 and add to be negative 3, negative 5, and 2. So, negative 5 and 2. Okay. Things that multiply to be negative 10, negative 5, and 2. Add to be negative 3, negative 5, and 2. I just diamond method it. Got it. Good question. You don't need to divide out a half because we changed our a value to 1 before we factored it. Very good question. Yeah, as long as your a value is 1 when we factor, you're good. Donzie. Good question. What does your discriminant find, you guys? How many solutions? Does it tell you where they are? No. A solution is an x-intercept. Good. That's what we need to remember. Okay, where are our x-intercepts? Positive 5 and 0 is 1. Where's the other one? Awesome. Those are our x-intercepts. Where's our axis of symmetry? Close. Draw it out. If you're all the way up here at 5, all the way here at negative 2, and I kid you not, this is how I sometimes do it, is start counting in one at a time towards each other. Negative 1, 4. 0, 3. 1, 2. What's between 1 and 2? 1.5. So that would be your your axis of symmetry would be at x equals 1.5. It's halfway between these 2 points. So your a is x. Always. Crazy question. You find that you only have one x-intercept. It happens. Even to the best of us. Yeah. So if you get asked how to find your axis of symmetry and you only get one x-intercept, it means that is your vertex, which means that is your axis of symmetry. It is tricky. It should be quicker if you know what's going on, though, right? Less work. Exactly. Okay. What's our vertex? Ebrock, yep. Exactly. So you go all the way back to your original equation. Way up here. You put in your axis of symmetry, 1.5, in there. Find what you get for y. So, y is equal to 0.5 times 1.5 squared minus 1.5 times 1.5 minus 5. Someone tell me what you get. Got a couple different
I
answers.
guess 6.125.
Yeah, it's like a.
Okay, give me 1 second. Negative 6.125. That's not your vertex, though. That's the y value of your vertex. So your vertex is at 1.5, comma, negative 6.125. Yeah, that's another way I'd use my graphic calculator, too. You could always check your answer. That's a great idea. So if you're doing a written question that's worth like 4 marks, and they want you to show your work, you can check your work by graphing it in your calculator. It's a great idea. Soccer.
Basically, even before, if they give you standard form, you just want to go back to this form so you can find everything from it.
If you're in vertex form, you can find everything from vertex form too, right? Your P is your X value for your vertex. Your Q is your Y value for your vertex. You can find your Y-intercept really easily by making X 0. And then you can find your X-intercepts a little bit harder by changing forms. Each form has an advantage, but you have to change it at some point to get all the information. Want to do one more together?
Yeah.
Okay, so we'll talk it all the way through again. So, identify the intercepts, the equation of axis symmetry, the coordinates of the vertex. What's the first intercept we know? What is it, Ryan? You got it? The y-intercept is where? The y-intercept is at 0, 10. Remember, y-intercepts, the x is always 0. What else do we know? Yeah, faces down. And we have a max point. How do we know we have a max and it faces down? Soccer, put your phone away. Do you need to move?
No, I'm good.
Colton, do you need to move? London, do you need to move? Someone was guilty. I don't know who, though.
Yeah,
Let's blame Colton.
Blame Colton. Okay. Colton just nod. Okay. Pay attention. How do you know it's down and max, Keely? Because you're right. Because the A value is negative, and when you're going down, you have to have a max. Good job. Okay, what else do we know in this form? Nothing. Nothing else you know. But what can we find? Everything. Let's find the x-intercepts. How do you find the x-intercepts? Someone with their hand up. Hunter. You factor it, okay? So, we're going to factor it, but we're going to make it equal to 0. Now, we don't like decimals. 0.5 suck. You have 2 choices in this question, though. You can take 2.5 out of all these things. They all go in nicely. So if you put in your calculator negative 7.5 divided by negative 2.5, it's 3. And if you do 10 divided by negative 2.5, it's negative 4. So we can factor that out. Always check to see if your A value factors out, because that's always your best solution. It makes things easy. So that's what we're going to do. Factor out a negative 2.5. Leaves us with x squared and then plus 3x, and then negative 4. Always check if your a value can go in, because that's the best solution. You did a test where 4.9 went into things. And if you checked, it made it really easy. If you didn't do that, you can still get it right. It just was a little bit more difficult. So always check that. Now, factor it. So, things that multiply to be negative 4 can add to be 3 will be 4 and negative 1. So we get 0 equals negative 2.5 times x minus 1 x plus 4.
I thought you didn't have to put that in front because you do it on both sides.
Okay, there's a difference. With this one, we multiplied everything by 2 to get rid of the 0.5. With this one, we factored something out. If you didn't put the negative 2.5, you're still exactly right. You're fine. So if you didn't do that, you're still okay. And the reason you're okay is you could have divided both sides by negative 2.5. 0 divided by anything is still 0. So you would have been okay if you forgot to put negative 2.5. You're still good. It won't change our answer, and that's a good question too. Your x-intercepts will still be the exact same. Your x-intercepts are still going to be 1 and negative 4. So the question was, does the negative 2.5 change your answer? It won't change your answer because your x-intercepts, remember, come from this being 0. So what makes this 0? 1. And the negative 2.5 times 0 will still be 0. And if you multiply it back in, you would still get the same intercept. So don't write this down. This is just for the sake of showing it. If we multiply that 2.5 in, we'd have negative 2.5x plus 2.5. What value of x would make that 0? It would still be 1. It's still the exact same x-intercept. Because negative 2.5 times 1 is negative 2.5. Plus 2.5 still makes it 0. So having a value out front doesn't affect your answer. Where are x-intercepts? 1 and 0, and negative 4 and 0. Right.
Like if because the other one
Boys. If you times this by 2, you still get the same answer. It'll always work out, whatever path you take. It will work out. Right, Ty? It'll still work, right? No, if you multiply everything by 2. Still works.
You're multiplying everything by 0, you're always trying to solve for 0. Like, that's the whole point of factoring, you're trying to solve that x equals 0.
Yeah, still works. Okay. What's the next thing we have to solve for? Where's your axis of symmetry going to be? Put it on a number line. You're at 1, you're at negative 4. Negative 3, 0. Negative 2, negative 1. What's happening between those? Negative 2.5. That's where your axis of symmetry is. Yeah, 1.5. I messed that first. What's up, Soccer?
I don't know, like, what I find like really works when you're finding your axis symmetry is just your x-intercepts together divided by 2.
That's another way of finding it. Yeah, you're fine. If you're doing it that way, that's fine. It's not wrong. This way it's nice because it's kind of visual, right? It's easy, it's visual. You're just getting through it by counting. What I did was I set up my two outer edges, my x-intercepts, -4 and 1, and I came in one at a time. So -3 and 0, one at a time. 2 and -1. And now I can't go any further, I'm going to run into each other. So I find the halfway point between those two. That's how I got my axis symmetry. So, 1.5. Okay, we have one more thing to solve for. What is it? How do you find your vertex, Ty? Unless you're asked to speak your motion. If you want to speak, put your hand up. Okay, too. Ty. You got it. Yeah, for x. So y is equal to -2.5 times 1.5 squared minus 7.5 times -1.5 plus 10. What do you get when you do all that? Alright.
I don't know, I got 26.8.
I got 26.
That's wrong, Ty.
Yeah, that's wrong. That's right.
It's 15.
Oh!
0.625.
Oh my god.
Okay.
It is positive.
Okay.
Oh, it's somewhere.
If you're having a hard time with your calculator, like if this isn't working out, you need to either go slower, so break it down into single steps in your calculator, or use more brackets in your calculator. So this 1.5 squared, that has to be in brackets. This negative 1. Yeah, but negative 1.5 squared will be a positive number. Yeah, but it doesn't matter. This one's negative 1.5. The first one doesn't matter. It's being squared. Anything squared is positive. Awesome. Your calculator would be rounded.
It didn't get the square to be positive, so
Oh yeah. That's weird. I'll take a look. The thing that matters is if you're not getting the right answers and you're doing all this work, is you need to go slower on your calculator. Like if, Hunter, if you look at what I did in your calculator, I do like 6 different calculations, right? Like it's slow. I do 1.5 squared. Then I times it by -2.5. And then I subtract that. And then I add 10 more. I go slow because I don't trust the calculator. Or my ability to work the calculator. Unedged. Yeah, if you are good enough with brackets, it'll work.
I just consider it going as x.
That would also work. If you're good with your calculator, do that.
Oh, that's way easier. Stored as x, so.
If you don't know how to do that, don't worry, don't learn it, don't confuse yourself. Mentor, don't teach anybody that. The last thing we need is people trying brand new things the day before test. Stay the course.
It works well.
No, I'm trying to talk stuff. People are just kind of doing their thing. Where is your vertex?
Vertex would be -1.5 and then comma 15.65.
Remember to write everything in coordinates. Asking for a point, write the point. Don't write y equals, don't write x equals, write the point. Okay. We are going to skip the sketching of the graph question for now. We'll come back to it if we have time. You can get by without knowing how to graph these things in your calculator. If you still need to graph things, like if you don't know how, then you need to do own practice on your own, or come talk to me. And I've been saying that for about a week, right? You guys should be good enough at this now. Talk.
Why are we gonna do one where it's just like
Letters? We're going to try to work our way to some of those.
Is there some in this book?
I think there's definitely some in your practice book. There's definitely some. There's some in there, and the answers are right for the ones with letters. Okay. We're going to fast forward all the way to this. The graph of a quadratic function passes through B3, 16. And the zeros of the function are 1 and 7. Write the equation of the graph in general form. That's a lot of blibber blabber, and you need to know what's going on. So, this is a literal point on the graph that the line crosses through. Yeah, they've labeled it point B. And it's an actual point on the graph that they've given you. This right here, what are zeros? They're x-intercepts. So they've given you 2 x-intercepts. So if we looked at our graph, we've got a point at 3, 16, point B. We also have an x-intercept at 1, and an x-intercept at 7. That's all we know.
I actually
That's a big thing. So if it says zeros, zeros is another word for x-intercept. Because those are the values that make y 0. That's where the term zeros comes from.
What's the full one? What's the y? What's where it is for y? For y is
instead of saying zeros, let's only bring you the y or something.
There is no other way of saying that. So like there's no cool way to say y-intercept. It's just always said y-intercept. So we don't know where the y-intercept is. Your x-intercepts.
I'm not going to get a question with the verse though that has a y labeled as the y-intercepts. That I decode.
You might.
I might, but how do I know if it's the y-intercepts? Like, what are
It'll say.
like the zeros are like kind of like a code word for the x.
Yes.
No code word for Y type.
There's no code word for y-intercepts. It'll say the y-intercept is.
Because it's cool, honestly. It never makes sense.
Dad, does what I'm saying make sense? Zeros means x-intercepts. There's no other way of saying y-intercepts.
So it's gonna just straight up tell us.
Yes. It'll say the y-intercept is.
Well,
He's just clarifying.
Yeah, that's all he's asking. He's asking a question.
Mumbo jumbo is just said.
Okay. Okay. We have to write an equation in general form. What does general form look like? What is it, Ebrian?
X squared plus B.
That's general form. Now here's the thing. You're never going to get general form given to you nicely. Like, they won't be able to give you points. It's like, oh, there's general form. You always have to start in a different form and get to general form. What form should we start in with the information we have? Hunter. Why factored? Because you have your x-intercepts, exactly. If you have your x-intercepts, you need to go into factored form, which looks like this. x, and I'm going to play, say, x. They usually write it like this. No, that's for other form. That's how they usually write it. We've always just said it's a times something times something. That's like the cool little factored form for it. Let me erase it. Doesn't really matter. What matters is we needed it in factored form. How's factored form going to look? Thanks, Commander.
Y equals A, and then like 3 plus, or no, x plus 1, x plus 7.
Okay. Right now, if you had that equation, what are your x-intercepts for that equation? -1 and -7. We want our x-intercepts to be +1 and +7. So if you're putting it into factored form, these have to be opposite. It has to be x minus 1, x minus 7. Now if you look at that equation, what are your x-intercepts? 1 and 7. Bingo. Ty. Ty, you're good. Just ask the question.
Okay. Since we have our like 2 x-intercepts, we can find the a value. That comes on the
Yeah, close. That's finding your vertex. Right, so we could find our axis of symmetry. We don't need to, though. What can we do, Logan?
Split that point into x and y, and then
Exactly. So, if you're looking at factored form right now, A, that's the value we need to find. So to find A, what are we going to do? And Logan, you said, what is it?
just take that point, take it short, but you don't have to pick a point.
Yep.
Just flip it with the x.
Exactly. So take your point B, because we know it's a point somewhere on the graph. Take the x, put it in everywhere you see x. Take the y, put it in everywhere you see y. So now it's 16 equals A times 3 minus 1 times 3 minus 7. You're subbing a value in for x and for y. That means 16 is equal to A times negative, sorry, that's positive, times 2 times negative 4. That's just negative 8, right? 4 times 2, negative 8. Divide both sides by negative 8. So 16 divided by negative 8 is equal to A. That means 2. Negative 2 is equal to A. Okay, the reason we found A is we needed it to be able to get into the form we wanted. So right now, this is where we're at. We draw a straight line down. Okay, this is where we are. We're in factored form. We have an A value, and we have 2 factors. If we want to go from factored form to general form, which that's our ultimate goal, how are we going to do that? Ty. Foil it. Foil it. So, y is equal to negative 2 times x times x gives me x squared. The outside values, x times negative 7 is negative 7x. The inside is x times negative 1, which is negative 1x. So that means negative 8x. And the last term is negative 1 times negative 7 is plus 7. Now you distribute your 2 in. Because this still isn't general form. General form doesn't have anything out front. So multiply that negative 2 into everything, and it's y is equal to negative 2x squared plus 16x minus 14. It is crazy, and none of it was really that hard, right? It's a lot. It's a lot of knowledge. It takes a lot of time, but nothing is that extreme. Exactly. Yeah. Foiling is just unfactoring. If, on your test, you start getting really crazy numbers, really big numbers, or just numbers that you know don't make sense, it's usually a sign that you've gone wrong somewhere, and to back up and try again. I guessed my way through a lot of university courses, and that golden rule saved me sometimes. Like it just, you're working, and all of a sudden you have like -1,300,006, and you're like, there's no way. And so you know you've screwed up. Do that on your test.
Barely passed.
Barely passed. I did really well my last 4 years. My first 2 years on so long. It's all about effort. The first 2 years I didn't put any effort in. I almost had 0. My last 4 years I did a lot better.
Yeah, how do you get a 0?
I got 100% the week before. It balanced out. Got 50. Didn't get one right. Didn't get anything.
But even guessing, I could get 20.
6. Here's another question. It's the exact same. Try it on your own. Write the equation into general form. Everything's the same. Try it on your own. I'll put the answer on the board so you can compare it. So, the very first thing and the most important thing is your setup. If you screw up your setup, you're kind of done. So, I put it into factored form. I used factored form because I had 2 zeros, or x-intercepts. Zeros and x-intercepts are the same thing. There's no fancy word for y-intercepts. Y-intercepts are y-intercepts. Okay. What's in factored form? I need to find my a value somehow. The only way you can find a variable is if there's only one variable, which means we need to change x to something, we need to change y to something. Thank you. To change our x and our y to actual values, we use the given point. 6 commas -60. We plug those values in, and then we solve. 6 plus 4 is 10. 6 minus 2 is 4. Multiply together is 40. Divide both sides by 40. I have -60 divided by 40 equals a. Calculator, math frac, a is equal to -3/2.
Yeah.
If you use -1.5, you're good. You're all right. Okay, bring it back up here. And I suggest you use fractions, just because that's where your lives are headed, that they're going to force you to use fractions. And if you use decimals, fine, right? Either way, you're fine. I'm just giving you a heads up. I'm just giving you a heads up that fractions are where your life is headed in math. Don't want it. Don't want it.
That's what's
Hey, you do. It's like
I then take that a value, sub it back into my factored form. I FOIL, and then I distribute it, and that's my answer. How did we do as a class? Pretty good? Pretty good. Okay. 11. Oh, page 11. I don't know if that's wrong. So, this question. There's another one like it in 3.2. It's the very end of the lesson. Those of you who have attempted it have come to me and asked me for help because it doesn't seem we can do it. You can't do this question yet. So put a big old X to this slide. It won't be on your test. It's part of our next unit. It's our next unit. I've just taken that part of the unit and put it in a couple weeks. Okay. The last slide. We can. We can, right now, as a class, do this question, or you guys can ask different questions about what's going on in this unit. Hand up if you want to do this question.
I have a question.
Hand up if you want to do this question. Hands up if you want to just ask questions for the next 10 minutes about this unit.
No, I'll wait for you to say that first.
Hands up if you want to do this question.
Wait, did you say the questions like this are gonna be on the test?
Yeah.
Yeah, let's do it.
Okay. Hands up. Soccer, what's your question?
Basically, these last two questions that we've done with you, if you can do these, are you?
Yeah, but remember, like it's more than just doing the question. It's understanding it.
Yeah.
Right? It's understanding, like, we've done things we've talked a lot about questions. We've talked about, does it open upwards, does it open downwards? We've sketched points. That's never been part of any of these questions. I'm doing that because that's the kind of stuff you need to know while doing questions. That's the kind of stuff you get tested on. There's a method to the madness. If you can do the work, that's a great, like, you have all the skills to do the test. But now you have to apply it. You have to have the knowledge to go with all the skills. Okay, let's do this one. A doorway is a parabolic arch. Parabolic means it's a parabola. Parabolas mean that.
Hey, don't make fun of the door.
The base of the door is 2 meters wide. So from here
That's a big door.
to here, it is 2 meters. At a point of 0.5 from one side of the doorway, it's 3 meters high. So if we come in 0.5 and go up, it's 3 meters.
I would never.
That's why drawing is so useful. Here's an arc door. 0.5 meters in, it's 3 meters high.
But like at a point, 0.
You're
like that confusing.
Yeah, it is confusing. I get it. I get that is confusing. Break it down word by word. A point, 0.5 from one side. So I started at a side, 0.5 meters from that side. The doorway is 3 meters high. 3 meters high. If you read the whole thing, it sounds like a lot of mishmash. If you just work your way there, it makes a little bit more sense. Okay. If you look at this right now, everything we do is graphs. Everything. So what information do we have? We have a point on the graph, right? Look, there's a point on this arc. What's that point up here?
0.5.
It's 0.5, comma 3. Okay? What other points do we have on this graph? Soccer.
Your x-intercepts.
We have 2 x-intercepts where it hits the ground. So if you imagine that we have put this on a plane, you have 2 x-intercepts. This one is 0, comma 0, and this one is 2, comma 0. Now, Dawson. Exactly. Yeah, good job. Emily, question? Okay. If you get a question, if it comes back to your ask. Dawson's point was, you have an axis of symmetry. You can see it right now. It's halfway. It's at 1. There's an axis of symmetry at 1, which means your vertex is also at 1. It's halfway, right? Okay, the question is, determine an equation to represent this arc. It doesn't say what type of equation. So if you want to do vertex form, if you want to do general form, if you want to do factored form, anything will work. I'm going to do factored form because I have two x-intercepts, two factors. So y is equal to a times x minus 2, because I have one x-intercept at 2, 0. The other one's a little tricky. It's just x. If you have a hard time figuring that out, put it in as x minus 0.
I would have done that.
X minus 0 is just x. Works out the same way.
That's zero.
You're fine. Yeah, you're good.
Wait, would you put minus 0 or plus 0?
Something minus 0 and something plus 0 is still doing nothing to it.
But then,
So you could have done both. You could have done x plus 0 or x minus. It wouldn't
I
matter.
was
Or just x.
Here's what you think.
Okay. Finding an a value. Use your point on the graph. So 3 is equal to a times 0.5 minus 2 times 0.5. If you plug that in, you're going to get, I think 4 is equal to a. Negative 4. Negative 4 is equal to a. All I did was simplify this, multiplied together, and then divided it to the other side. Put that negative 4 in for a, that's your equation. It didn't ask for a specific form. So my answer is y equals negative 4 times x minus 2 times x. That's an equation. It represents this arc. Now it says, could an item that's 3.5 meters fit through the doorway? And Dawson said, you can find the maximum height. How do you find the maximum height? It's the vertex, yeah, Ellen. It's the vertex. That's where your maximum height is going to be. So you need to find what that maximum height is. If it's greater than 3.5, it would fit. If it's less than 3.5, it won't fit. To find that vertex, use your axis of symmetry. Your x is 1. Right? We know that at the vertex, it's 1, comma, something. We know it's 1 because it's halfway in between 0 and 2. So our vertex is at 1, comma, we don't know. That's what we're going to find out. So put 1 in for x.
The originals.
Yeah, to our equation we created. Negative 4 times 1 minus 2 times 1. Y is equal to 4. Yeah. Put 1 in for x. That gives us y equals 4. In the context of this question, what does y mean? Y is the height of the arc. So could something that's 3.5 meters fit through the doorway? As long as it's skinny enough, it could fit. Ebra.
So x, are you on the end? Are you adding it?
Multiplying it. And then x minus 2 times x. Yeah. All right, keep studying, guys.